In this problem, quadrilateral CHMZ, which is shown down below, what you are asked to do is to dilate the figure with a scale factor of 1/2 with the origin being at the center. So the origin is the center of dilation. So what that means is that 0, 0 is the center. And the easiest way to do this is to do a method of rise over run to get to each individual point. So for example, I can see that to get from the center of dilation to C, we're going to rise 2, and we're going to run 2 to the right. Well, half of that would happen to be 1 up, 1 to the right. So that is where we will put the first point. So at 1, 1 from the origin. So that would be C prime. Next, we would do the same thing for H from the origin. So to get to H, you're rising 4 and you are running 4 to the right. Well, half of that is from the origin, and you always have to go back to the origin, is rising 2 and running 2. So right there would be H prime. Point M from the center of dilation, the origin, we are rising 3 and we are running 6 to the right. Half of each of those would be up 1.5 and running 3 to the right. So there is M prime. And then we do the same thing for Z. Go back to the origin. Notice that we do not have to go up to get to Z. We're simply going to the right 6. Half of that is 3, and then always return from where you started. In the next problem, we have triangle DFW that we are dilating with a scale factor of 2, and once again, our center of dilation is at 0, 0. So, if our center is at 0, 0, which that of course would be right here, and the easiest way is by using the method of rising and running. So to get to the first point D here, we are rising 2 and running 2 to the right. Our scale factor has to be 2, so you're going to go twice or 2 times that rise over run. So if I take that off of there, and 2 times 2 is 4, so we're rising 4 from the origin. And I didn't mean to put a point yet. So we're rising 4 and we're running 4, and that would be where D prime would be located. Once again, double from where D was. Returning to the origin, F is rising 6, running 4. So F prime from the origin would be double that, rising 12, running 8. And W is rising 1 from the origin, running 5. Double that would be rising 2 and running 10. And then we return to the starting point. Sometimes we do dilations where the center of dilation is not at the origin. In this case, we can see that the center is out here at -3, 3, as it states in the problem. But the method of creating a dilation is exactly the same from that center. So this time, we will be starting from -3, 3. So to get to the first point, if I'm trying to get to point C, I'm going to be going down 1 and right 1, 2, 3, 4. Our scale factor is supposed to be 2, so we have to go double that. So down 2, right 1, 2, 3, 4, 5, 6, 7, 8. That would be where C prime would be. Maybe go to H next. We're rising 1, 2, 3, 4, 5 from the center of dilation and running 1, 2, 3, 4, 5, 6, 7, 8. Double that would be running 10, running 16. So that would take us out to +13, going from -3 to +3. And that is where I'm not really sure what happened there, so let me go again. Down to right 8. There's C prime. Up 5, right 8, so up 10, right 16. All right, and then point M is down 1, right 11. Double that is down 2, right 22. So that would take us out to positive 19. And then you would return back to the original spot. Pay no attention to all those extra dots down there. I accidentally hit a button. So once again, that shouldn't be there. And that would be a dilation with the center at -3, with a scale factor of 2. So the blue triangle is twice as far and twice as big as the red triangle. Here's another dilation where the center is not at the origin. So in this particular problem, the center is at 2, 1 right here, and the scale factor is 1/2. So we have to go half as far from the center. So point B is straight up 5. Half of that is straight up 2.5. So right there is B prime. And point F from the center is up 4. Right 1, 2, 3. Half of that is up 2 from the origin. And right 1.5. 1.5. So there's F prime. And then K is up 2, right 6 from the, not from the origin, but the center of dilation. So half of that would be up 1, right 3, and then we return from the starting point. In this problem, we have triangle BGP that is plotted on the grid below. It says if the triangle is dilated with the origin as the center of dilation, which ordered pairs could represent the image of point P 5, 2 after the dilation? Well, anytime the center of dilation is at the origin, we're simply multiplying both the x and y value by the same numbers. So if point P is 5, 2, and we take that point right there, 20, 8, we can see that we are multiplying by 4 and by 4. So that point would work because that would mean the scale factor is 4. So we know that 20, 8 will definitely work. If we try the same thing with 10, 4, we can see that we're multiplying the x value by 2 and the y value by the same thing. So that one will also, could be a point that is on the image. 10, 5, that's not going to work because we would be multiplying by 2 for the x value, but by 2.5 for the y value. That's not the same. So that one's not going to work. Obviously, 10, 20 is not going to work because we would be multiplying by 2 there and by 10 there. And remember, we're starting with 5, 2. I've got a mess here. But 40, 4 obviously is no as well because we're multiplying by 8 for the x value and 2 for the y value. You would have to be multiplying both the x and y value by the same value. So both of those could be ordered pairs that would represent the image of P, in other words, P prime after a dilation. In this problem, we have triangle CEW dilated by a scale factor of 4 with the origin as the center of dilation. Whenever the center of dilation is at the origin, it makes problems like this much, much easier. So if we think about what point C is 1, 6. Point E is 6, 5. Point W is 9, 1. If the scale factor is 4, then all you really need to do is multiply both the x and y values by 4. So C prime would be 4 comma 24. E prime would be 24 comma 20. Once again, multiplying both the x and y values by 4. And W prime would be 36 comma 4. The easiest way to find the center of dilation with two shapes is to simply connect each of the corresponding vertices together. By corresponding vertices, we're talking about the corners that are really lined up with one another. So those two are corresponding vertices. These two are corresponding vertices. And these two are corresponding vertices. So if we connect each of the corresponding corners or vertices together, we will quickly see what the center of dilation would be. So to do this, in my open math, we can just simply use the line tool. So now we'll connect D and L together. Those are corresponding vertices, and F and N, and then we can easily see right here is the center of dilation. So the center of dilation would be, in this particular problem, 2, comma 2. In this problem, we have triangle CGW. It's dilated from the origin at 0, comma 0. And we also have the image of it after a dilation, C prime, G prime, W prime. The question is, what is the scale factor? The easiest way probably to do this, and there are lots of ways, but one way is to simply use the method of rise over run. And we always have to start here and end here. So that's the second one. So to go from from the origin to point C, we are rising 4 and we are running 1. Well, to get to C prime, we are rising 2 and running 1/2. So you can see, to get the difference between C and C prime is half as far. So that would mean that the scale factor is 1/2. Using the method of rise over run, we're going to try and figure out what the scale factor is here. And so this is the shape that we're going to start with, because there's no tick marks next to the letters. So here, from the origin is where the center is. So we'll start right here. We are rising 4 and running 2. To get to the image, we are from the origin. We are rising, it looks like we're rising 12 there, and running 6. So the red triangle, it looks like it is 3 times as far as the original green triangle, so that would make the scale factor 3. And the thing that you have to remember from 7th grade is, if the shape gets bigger or larger, the scale factor is some value greater than 1. If the shape gets smaller, the scale factor is some value between 0 and 1. And if the shape was exactly the same size, the scale factor would be exactly 1.